Good evening. Today I'm going to introduce our new project. Name is Automatic Traffic Intensity Tracker. What is an automatic traffic intensity tracker? It is a software that used in the traffic signal or somewhere else for vehicle detection and counting. Vehicle detection and counting is detecting vehicles such as cars, bikes, and check its count for some purposes. We have an introduction for this. Let's go to our introduction. What is a vehicle detection and counting? Vehicle detection and statistics in highway monitoring video scenes are of considerable significance to intelligent traffic management and control of the highway. Vehicle detection and counting system is mainly used in the traffic signal for some traffic purposes such as detecting vehicles and detecting number plates and detecting color or other some specific features of vehicles in the highway or in the traffic signal. We are mainly concentrated in car detection and counting using image processing. We have some objectives. Let's check it out. Our objectives: vehicle counting and detection system. It will be enough to work for both image or the video. For the same, we will using we OpenCV for doing all image processing operation and classification. Car and bus using HAR cascade classifier for detecting and counting cars, bus, and etc. Having you can also make your HAR cascade classifier. There are some benefits or advantages of this software, that is help to traffic police and maintaining records and traffic surveillance control. How to help traffic police? That is, a vehicle detection and counting system could be beneficial for the traffic police because everything they can monitor from one place only crossed this toll and which vehicle. And then other one is maintaining records. It is challenging for some individual to record all the vehicles with them because the cars are passing by in real time. It is not like that one is watching the video and they can pause it and have a note of it. So to remove the limitation, and the application can be very well was to attain the time saving quality and automated. The last one is traffic surveillance control, as this application can be planted anywhere as it only requires a camera or some wires. Hence, if the traffic is high at some place, then from the area an officer to monitor it and forward the information to next to toll officer so that they could be prepared beforehand. Our next step is method or methodology. There are many methods of detecting vehicle on road, such as motion detection, installing lasers on both sides of the road. But we mainly concentrated is based on vehicle detection using image processing. Or we mainly concentrated in car detection using image processing. Then let's move to our algorithm section. First step is take the image from the internet or somewhere else. Then put it color to grayscale algorithm for changing image color. And the next step is traffic detection using cascading. Let's check something about our algorithm section. First step is the image color is change the color of the image to grayscale algorithm. Uh, then traffic detecting detection using cascading classifiers, and another one is traffic detecting and counting process. What is our system requirements? We have an operating system that Windows 7 or above, and another one is Python, and our backend is Python OpenCV. We all knew about Python. Python is open source software or loosely typed software for coding and other purposes. We installed some libraries in our Python, ideally that is Python OpenCV and Python Pillow, etc. What is Python OpenCV? OpenCV is a popular computer vision library started by Intel in 1999. The cross-platform library sets its focus on real-time image processing and including patent-free implementation of the latest computer vision algorithm. Vehicle detection and classification counting system using the YOLO algorithm along with OpenCV to detect a classify and detect and classifying vehicles. What is YOLO? YOLO stands for you only look once. It is a real-time object recognition algorithm. It can classify and localize multiple objects in a single frame. YOLO is a very fast and accurate algorithm for its simpler network architecture. The final and last uh, method of our project, that is experimental analysis and a result. Let's go to our experiment section. We all done about after installation of all libraries, then reading the image from the URL or reading image from installed in our desktop. Uh, then changing the image color to grayscale algorithm, gray equal to CV2, CV2 color image, put the image there, and then it also changed to color gray for burst detection process. The another step is detecting cars using car cascade or har cascading tool. We used within cars.xml file for detecting or framing cars inside the image and counting them. The last portion of our project or program is counting the cars and it numbers. You can see the picture in the sliding window. There are so many cars and the red rectangle is detecting the cars or detected the cars, and there is an output 21 cars found. This is the experimental and result concept of or result concept of our project. Let's move to the practical section of our project. You can see the program in the frame. It is the main interface of our program. The first step is installing some libraries. We installed some libraries such as Python, OpenCV, and Python Pill, NumPy, and requests for the purpose for some specific purpose inside the program. And the next step is take an image from the URL or from the desktop. Then change its size to a specific size format, then changing some features such as changing its color to gray and changing its size to some specific size. After all, using car cascade method to change the cars images to a rectangle frame and detect count the vehicles inside the images. Let's check its practical output section. Now I am calling an image from the network using a path such as HTTP A57, and then check its output section. Oh, the output comes. Let's check the output. There is there are so many cars, and you can see the red rectangle specifies all cars. Then its count is there. 22 cars found from the image. If we put some image such as only one car, then detect it one car or one car found. Let's check it out. The next step is put another image to the program. I put this image to our program. Let's check what output will become to, or what output will generate. Let's check it out. I put the name of the image, that is 3.jpg, and comment the above URL using hash function. Then check it the output. What the hell is Oh, there is some error. Let's check the new output. Let's go to the debugging session, then debugging. Yeah, you can see the frame, only one car in this picture, and the frame detect the car, the red car. Then the output becomes one car found. Then let's go to check if there is, if an image there is two car and one bus, how to detect the XML file. And let's go to check it out. I'm going to put this image to the program. You can see there is a two car and one bus. Then how to detect this image using our program. Let's go to check it out. I texted the image name 2.jpg here, and let's go to the debugging process. What will be the output? Let's go. You can see the rectangle frame detect one car and the another car, but the bus remains constant here. There are no frame to detect the bus, so project, or you can see there is an output become two cars found. We can see there only two car and one bus. The frame detected, or the XML file detected two cars here, but the bus remains same. So this is our basic output of our project. This is the major functions of a project. We used the cars.xml file for car cascading tool to detect cars inside the cars from the image, and framing and counting cars inside the image. It's enough. Our project is a set type project. I know it's not 100% satisfied, but we put our all strength to this project. I believe 92 or 4% success. Thank you so much for watching.